The force of one of these space rocks equals 10,000 Hiroshima bombs, pressed into a piece of land a mile across. Oumuamua, a puzzling object that once zipped through our nearby planet group, has again sent shock waves through mainstream researchers. Elon Musk, a noticeable trailblazer in space innovation, revealed that Oumuamua is back, and this time it's not alone in its excursion. Elon Musk promises that its mysterious qualities contain enticing clues to other star systems. This isn't the regular return of a divine element. Its return challenges how we might interpret space and its potential tenets. Join us as we unravel the implications and secrets surrounding Oumuamua's startling return. Back in 1837, an unusual object achieved a prominent cosmic feat. It crossed a distance of 1,000 galactic units from the Sun. For north of a century, this object continued its journey, inconspicuous, steadily progressing towards our star. It was only after October 19, 2017, that mankind finally became aware of its presence. On that particular day, an image captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a faint, fragile streak navigating the sky at a consistent speed, covering approximately 6.2 astronomical units every day. This mark denoted a significant moment. It was the first recorded interstellar visitor, officially designated as 1I/2017 U1. This object was also given the name Oumuamua, meaning a messenger from afar in Hawaiian. The discovery ignited a global drive to observe Oumuamua through telescopes. Space astronomers, including those from the SETI Institute, eagerly participated in observing the object, even sending off searches for potential extraterrestrial signals. Oumuamua appeared like a reddish cigar-shaped object comprised of rock. Its elongated shape is striking, stretching up to 4 miles long and significantly longer than it is wide. Oumuamua has an aspect ratio that surpasses any asteroid or comet observed in our planetary system. Its elongated shape is very unusual and unlike anything we've seen before. Oumuamua was traveling at a speed of 196,000 miles per hour when it drew near to Earth. That's over 10 times faster than a bullet, which means it's highly unlikely that this object was part of our planetary system. Initially, scientists couldn't determine whether Oumuamua was an asteroid or a comet. So what's the difference between the two? Comets are made out of ice, while asteroids are rock. Initially, scientists thought it was a comet, but their classification changed to calling it an asteroid once it zipped past the Sun on September 9, 2017. However, they still considered it an asteroid until additional measurements showed a slight acceleration, indicating it was a comet. But the fact that Oumuamua accelerated more than expected puzzled scientists for years. An exceptional quality of Oumuamua was its periodic brightening and dimming every 7.3 hours. This behavior indicated its rotation around its short axis. Such a decay pattern suggested a more rigid and solid composition than the typically soft, snow-like material of most comets. Appearing dull red, like specific moons in the outer planetary system impacted by space radiation, Oumuamua's color could also include iron, as suggested by Dr. Meach, a cosmologist at the University of Hawaii's Institute. Despite these insights, Oumuamua's origin and nature remain a mystery. This trajectory puzzled scientists, indicating something beyond conventional explanations. Different theories emerged to decipher Oumuamua's identity. While some trusted it to be a rock, others suggested it was made of gas. Incredibly, a subset of researchers even entertained the possibility that it might be an alien spacecraft. This raises the fascinating question: could an extraterrestrial mothership someday explore our planetary system and send smaller probes to explore planets? In the subsequent segment of this video, we will delve deeper into these secrets. But first, let's examine the range of scientific hypotheses that have been put forward to interpret the origin of Oumuamua. Dr. Meach proposed the idea that it could have been flung out from a distant star following a cosmic explosion or perhaps formed when two objects collided. Additionally, Elon Musk and cosmologists were initially excited when they saw the trajectory. It seemed to point towards Vega, the brightest star in the Lyra constellation, known to have a debris disk. Calculations showed that this object might have come from Vega to our location in around 600,000 years. However, the likelihood of Vega being the actual source has diminished due to significant changes in its path. It's believed that Oumuamua encountered a new star system for the first time, considering its motion around the Sun, which was similar to the speed of neighboring stars. However, there's a possibility, as suggested in nature, that Oumuamua could have been traveling around the universe for billions of years. We're uncertain about its forthcoming trajectory. Imagine it like this. Remember how the Voyager spacecraft got a boost in speed from Jupiter? Well, Oumuamua is also gaining speed from the Sun, pushing it faster and somewhere new. Dr. Meech explained that this asteroid, along with its peers, alters our view of the world. When you look up at stars appearing distant and separated, it contrasts with what these space rocks reveal. They tell us that things are interconnected and unique. The oxygen and iron inside our blood emerged from a massive explosion in a distant place long ago. Bright things like wedding rings resulted from the collision of superdense stars and those meteorites plunging to Earth. Some of them originated from Mars due to asteroid impacts. Remarkably, some esteemed scientists consider that these meteorites might have carried life from Mars to Earth during a time when Mars enjoyed warm and wet conditions. Life could have started there and then hitched a ride on those meteorites to Earth. It's a bold idea, but it's being considered by respected astronomers. Our connection with the universe can be traced even further back in time. Ponder the countless years Oumuamua could have taken to arrive here. While that might seem extensive, it's just a fleeting moment on the cosmic scale. The Milky Way galaxy boasts an age of 10 billion years. Throughout this vast time frame, Oumuamua could have traversed approximately 20,000 star systems, a modest fraction compared to the galaxy's 200 billion stars, yet still countless astronomical encounters. Oumuamua would have trailed behind dust and debris, allowing the stars and galaxies of the Milky Way to mix. This suggests that the universe may be smaller in scope than previously thought. Even if it's no longer within our immediate view, the planetary system hasn't abandoned it. Currently, Elon Musk and other astronomers anticipate that Oumuamua will enter the Kuiper Belt around 2024 and cross its edge by late 2025. He also estimates that it will pass Voyager's most distant point in 38 years. However, since Oumuamua has been distant for astronomers, they are making the most of the data gathered in just a few months to grasp as much as possible about this intriguing interstellar intruder. Initially confused with an asteroid due to its size of around 2,600 feet long and 260 feet in width, Oumuamua exhibited unpredictable behavior in its trajectory. Astronomers and researchers noticed a remarkable non-gravitational acceleration, indicating that forces beyond gravity were at play in its motion. Dr. Meech figured out that several factors could lead to this acceleration. Her team investigated at least 6 potential causes, eliminating some due to their impossibility or inconsistency with observations. One likely explanation was comet outgassing. A common occurrence in comets, outgassing happens when a comet draws near the Sun and its surface ice sublimates, turning directly from solid to gas. This cycle gives the comet an additional push, altering its speed and rotation beyond gravitational influence. This change in motion resembles the behavior of Oumuamua, aligning with the force observed in comets. Notably, the absence of emerging dust from Oumuamua was intriguing. Typically, as gas leaves a comet, it carries surface dust with it. However, Dr. Meech asserts that even if the comet lacked microscopic material, the presumed presence of significant dust on its surface could have affected its speed. This idea kept the possibility of it being a comet alive. Researchers principally analyzed visible frequencies, making it challenging to therefore identify large residue particles. No apparent proof of residue leaving Oumuamua was noticed. The shortfall of gas-related signs was likewise perplexing. Shockingly, cosmologists anticipated a noticeable amount of gas emission to impact Oumuamua's speed in the way observed. Dr. Meech's group explicitly looked for CN gas, a substance that she notes is bright and easily recognizable. It serves as a proxy for water, which is harder to monitor. Since CN is often emitted from comets in our planetary system alongside water, the absence of CN gas was unexpected. In spite of their efforts, no CN gas was detected within their detection limits. Considering that comets in our planetary system can hold significant amounts of water, the absence of CN gas showed that this comet was chemically unique. Dr. Meach figures that if a large volume of water were to be produced, it would likely originate from a different nearby planet group, and this could account for this unusual finding. Cosmologists used the Spitzer Space Telescope to observe Oumuamua in the infrared for north of 30 hours, attempting to identify its thermal characteristics. However, they encountered challenges in their undertaking. Dr. Meach explains that the thermal infrared detects heat emissions, and in this case, their observation yielded no observable results. Interestingly, even non-detections can offer insights. In this case, they reasoned that Oumuamua should be brighter than expected if it displays thermal behaviors similar to a comet. The reflectivity of an object, or how much light it reflects, can reveal details about its size, composition, and shape. We generally expect the reflectivity to be low, like that of comets, around 4% reflectance. However, they were getting readings around 10 reflectivities, rather than the standard 4%. So, once again, it doesn't quite fit the profile of a comet. To make it match that 4% reflectivity, you'd need to assume it has significantly different thermal properties on its surface compared to other comets. This is another interesting peculiarity. Moreover, during the same infrared examinations, no perceivable carbon monoxide or carbon dioxide outgassing from Oumuamua was seen. This finding holds significance since Meach's group had been considering how possible it is that Oumuamua was producing these two gases in larger amounts than the Spitzer's observation limits suggested. By Meach's explanation, it's a little challenging to deduce much as far as you don't tell, but again, it doesn't seem to act like a regular comet. Given that Oumuamua hailed from a different nearby planet group, these peculiarities could be typical for objects originating from other star systems. The trajectory of Oumuamua was meticulously traced back to before its initial entry into our nearby planet group by Corin Baylor-Jones from the Max Planck Institute for Astronomy. Comparing this path with the past positions of 7 million stars tracked by the Gaia satellite, Baylor-Jones rewound both Oumuamua and the star's orbits to identify potential signs of crossover. Out of the stars with trajectories that approached sufficiently close to Oumuamua's rewound path, 4 candidates stood out as potential contenders for its home. Elon Musk claims that Oumuamua's trajectory had met within a range of 1 to 2 or 100,000 to 200,000 astronomical units. However, as Baylor-Jones was stargazing, frequent complications arose. The escape speeds of these candidates were relatively high, ranging from around 6 to 16 meters per second. A potential difficulty is that Oumuamua is most likely a planetesimal, a structure cast out during the formation of planets. It's rare for planetesimals to achieve escape speeds this high solely through interactions with large planets. Our predictions would have suggested speeds of only a few meters per second. While these speeds are high, they are not impossible but highly improbable. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, the candidates were not necessarily recognized as double stars. Typically, approaching data releases from the Gaia mission could help astronomers in identifying a more suitable source for Oumuamua by offering further insights into the movements of neighboring stars. In a few years, it would be fascinating to revisit this, the first and so far only extraterrestrial visitor we've observed navigating our planetary group. As Oumuamua remains even with the limited data available, regardless of its mysterious nature, experts worldwide are fascinated by its potential secrets. Oumuamua continues to intrigue due to its unique attributes. Now, it would seem Oumuamua isn't alone. Back on August 30, 2019, Gennady Borisov, an amateur cosmologist at the Margot Observatory in Crimea, detected another comet named 2I/Borisov. This comet was racing through space at an astounding pace of 93,000 miles per hour, 150,000 kilometers, faster than what you'd expect for an object situated around $2.80 away from the Sun. What caught our eye, other than its speed, was its TR trajectory. It was plunging into the interplanetary group at an angle of 40 degrees relative to the ecliptic plane, on a path marked by an incredibly high eccentricity of 3.7. This indicated that, similar to Oumuamua, Borisov also had an extrasolar origin distinct from our solar system. Borisov showed a clear tail, indisputably marking it as a comet. Its trajectory was taking it toward the Sun, expecting to reach its closest point on December 8, 2019, at around $2 from our star. This would potentially illuminate before darkening again, possibly reaching magnitude 15 by its closest pass to Earth on December 28. Even after it dimmed for amateur spectators, experts could continue tracking Borisov until October 2020. Dr. Mich's team first observed Borisov and estimated its size to be between 1.2 and 10 miles in October 2019. They noticed the emission of CN gas from its surface. However, the comet's faintness prevented detecting other gases. However, the prolonged year of observation provided by 2I's trajectory offered a unique opportunity to explore its chemistry. This stands in contrast to Oumuamua, which didn't allow for detailed chemical analysis due to potential obstructions from gas and dust. This extended observation will shed light on 2I/Borisov's characteristics. 2I/Borisov is its peculiar comet-like appearance, making it a reddish traveler that aligns more with our familiar understanding of local planetary group comets. This disparity highlights the diversity in interstellar objects. Such differences are invaluable for astronomers striving to understand the processes shaping other nearby planetary systems, whether similar or distinct from our own. This ongoing exploration expands our perspective on the wider universe. Meanwhile, some astronomers have ventured to suggest that Oumuamua may be of extraterrestrial origin. Adding to the intrigue, a draft paper by a Harvard scientist and the head of the Pentagon's UFO office proposed the possibility of an extraterrestrial mothership within the planetary group, dispatching tiny tests akin to dandelion seeds to explore the planets. The revelation of this report came from Sean M. Kirkpatrick, the director of the Pentagon's Everything Area Anomaly Resolution Office, AO, laid out in July 2022 by the Department of Defense, DoD, to identify and investigate intriguing objects. Collaborating on this draft study alongside the DoD was Avi Loeb, a cosmologist at Harvard University. However, noting that it's significant, the study is not an official Pentagon document. Avi Loeb is famous for his research on Oumuamua, having even proposed the possibility that Oumuamua may be an extraterrestrial space probe 6 months before Oumuamua's close approach to Earth. A small interstellar meteor approximately 3 meters in diameter struck our planet. Although inconsequential to Oumuamua, this meteor, known as M2, caught Loeb's eye. By chance, Loeb considered how possible it is that an artificial interstellar object could act as a parent craft, releasing multiple small probes during its passage near Earth, an idea akin to NASA's spacecraft missions. The gravitational force from the Sun or the craft's propulsion may detach these dandelion seeds from their parent vessel. In their draft paper, Loeb and Kirkpatrick delved into unidentified aerial phenomena, UAPs, a term preferred by the government for UFOs. While adhering to outlined physics, the researchers speculated that the dandelion seed probes could travel to Earth for observation without being detectable by survey telescopes, logically due to their small size, which would limit their sunlight reflection. According to their proposal, the technology of these probes could enable them to slow down in Earth's atmosphere to prevent burning up, thus utilizing their parachute-like mechanisms to navigate to their intended destinations after landing. Logical conjectures suggest that alien civilizations could aspire to study rocky planets with atmospheres within our planetary system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest. After identifying signs of liquid water, the mothership wouldn't be required to be home to the advanced extraterrestrial civilization that created the probes. The possibility of the mothership communicating with these probes is also uncertain. The idea that a habitable planet with intelligent life could have dispatched probes long before Earth existed is an intriguing suggestion. Loeb compares it to occasionally checking our mailbox for accumulated packages, even if the shippers are no longer extant. Loeb has faced skepticism from mainstream scientists since he first proposed the possibility.